Okay. Any doubts from yesterday's session? Before getting into architecture detail, I just want to have a small recap on yesterday's session. So, so before getting into that, if you guys have any questions from yesterday's session, I'll clarify them. Then we'll move into that for the slides. Okay. Yesterday we have seen what is a Hadoop, and we have seen some history of it, and we have seen what is a DFS, and what is it, and we have seen HDFS as well, and we saw the difference between DFS and HDFS. And so, any doubts from what is a DFS or what is a HDFS? Any doubts? I'll start clarify them. DFS is a distributed file system where the multiple machines are there in the cluster. I mean, I can say in the network. So multiple machines will be connected each other in the network, and they will be having a central namespace, and we have to have a shared directory. When we try to access data from DFS, distributed file system, it looks like a single repository where we're able to get the data from DFS network. I can say the best example is NFS system from Microsoft. But the problem with the DFS, the whole data, data belongs to one type of data. I can say for employee or stock or student or any kind of data will be belongs to, I mean, the data which belongs to a specific file or specific data will go into one machine. So if any failure happen, any machine is gone down or something happened with that machine, we may not be able to recover it. And another problem is, if I want to process some data, I want to retrieve or I want to do some analysis on that data, because of it is stored in only one machine, the the machine may take much time to process it, because it is not a parallel passion. I mean, it's not a parallel processing passion, right? Yeah. So that is a DFS. What is then HDFS? HDFS stands for Hadoop Distributed File System. This is also a distributed file system where we'll store the data into multiple computers or multiple servers. The HDFS made up of two nodes, and getting into that, we'll see what is a node. We'll just familiar with the terminology. Node, yeah. So we'll get familiar with the what is a node and what is a daemon, what is a cluster, and how it is a Hadoop cluster. A node is a machine or physical device which is connected in the network, and where we can interact with it, where we can store the data, where we can get the data through it. That is node, a physical entity, I can say, which is connected into a network, a physical machine where you can interact. And what is a daemon? So daemon is a technical term to use or describe a background process which will not depend on user. The background, when an action is occurred, or when you have hit something, or when you executed a command, it will start executing the background process. Ideally, when any process running on the Linux machine will say daemons. Clear, guys? What is a node and what is a daemon? Okay. Then what is a cluster? The cluster is a group of servers. So cluster is a group of servers and other resources that act as a single system. You won't feel that you are talking with multiple machines. Being a client, when you want to store data, or when you want to retrieve data, you won't feel you are talking with a multiple machines, right? So it may connected multiple missions, but when you're trying to interact with it, you will be you will be feeling that you are talking with one single mission only, which is highly available, I can say, and where it can have a load balancing and parallel processing also can be available with that. Okay, then what is a Hadoop cluster? As I said, Hadoop cluster is made up of two main nodes. One is a name node, another one is a data node. As I said, node is a technical term for a physical entity or physical machine which is there in the network. Then what is the difference between normal cluster and Hadoop cluster? Hadoop cluster is a special type of computational cluster. It means that it has a special software which needs to install on the machines, and which is designed for which is designed this Hadoop cluster to store large amount of the data, the huge amount of the data, to store it and process it efficiently or process it parallelly. Clear guys about node, daemons and Hadoop cluster? If you guys are clear, I'll move to next slides. I hope I'm audible to everyone and everyone able to see my screen. If anyone is facing my screen, go ahead.
Here, Jay,
Hi Jay, go ahead.
see how the difference between the cluster and the Hadoop cluster is it a subset of Hadoop cluster or
No,
like how the
both are similar, but when it comes to the Hadoop cluster, we will be installing a special software on the cluster, which is mainly designed for storing the main huge amount of the data. Both are similar, but when you install the Hadoop software in that cluster, we'll say it is a Hadoop cluster.
okay in terms of cluster means the, is the general word and Hadoop cluster is the only specific to
Hadoop,
Hadoop
exactly,
technology.
exactly.
Okay.
Yep. Shall I move to next slide? Okay. If you see, the Hadoop cluster looks like is in this. I mean, it looks like this as I shown on my screen in the real time. And if you get a chance to look into the server rooms, and the cluster will be looks like this. There will be racks in that you'll be having a computational machines. Here, as I shown, sorry, as I shown, this it is a rack. This is a rack, and these are the nodes. These are the nodes. Node is, as I said, is a physical entity. Though this is the node, which contains a hard disk, a processor, and a RAM. Okay, and when we made a cluster in the rack, collection of nodes is a cluster. As I said, collection of computer or collection of servers in the rack in the network is a node. So when you see this diagram, the cluster will be made up by using the systems will be our servers will be installed in multiple racks. What is a rack? A rack is a technical term for where we can keep a collection of systems I mean in a row or in a column. When you want to keep multiple machines in one after one or in a it's like a normal rack. It's a normal term for the rack. Okay, it looks like this. These are the racks. I can say here this is one rack, uh, and this is one rack, and this is one rack, and this is one rack. These are the racks. So when it comes to the nodes, these are the nodes. The nodes is not required to have a monitor, and they, when you see in the server rooms, they'll be having special kind of monitors or special laptops where they will. It's not a special laptop, normal laptop as well. They will connect to the rack or connect to the cluster, and they can go ahead and check what is the state and what is the health of it, whether is any node is gone down, so they can go ahead and check. Okay, on these nodes, on these machines, where you installed a software, a Hadoop software, we call them as a Hadoop cluster. Means that cluster is made up for the specific purpose, like where you can store the huge amount of the data, where you can process that data. That cluster will call as a Hadoop cluster. The Hadoop cluster,
Uh,
yeah, go ahead.
can you go back to the previous slide, like one more back,
Yeah,
one more back.
okay.
So here are the entities, node, demands, cluster, and all are physical thing, or is it like any logical in the?
Okay, daemons are a logical thing. Daemons are the processor which are running backend. We will not be see them. We cannot able to see them. It's a process.
Okay, rest
Node,
all are physical entities
yes,
basically.
rest are all
Am I-
physical entities. Correct. Node is a physical machine.
Okay,
Okay.
so cluster also is again physical information actually.
Collection
You mean
of
to say?
collection of is a group of servers.
Yeah, correct. Okay,
Okay, group of machines or group of nodes.
okay.
Okay, all are clear. Anyone has any doubts? Okay, then I'm moving to the next slides. So the clusters looks like this. Okay, now Hadoop cluster. When it comes, the Hadoop cluster looks like this. This is a rack one which contains multiple nodes or multiple hardware devices, and these racks are internally connected with the switches, the high bandwidth network. Okay, now the Hadoop cluster is made up of, as I said, two main nodes. One is a name node, another one is a data node, and we'll talk about the daemons in the later. As I said, node is nothing but a technical term for a hardware, which is or a server or a machine which is there in the network. And again, a data node or name node are some physical machines here. And when I say name node is a master node, and when I say data node is a slave node. The Hadoop follows a master slave architecture. The Hadoop follows master slave architecture. 1 second, guys. Let me make it clear. Okay. So our Hadoop architecture is 1 second, guys. As I said, it's a Hadoop architecture is made up of master master slave architecture. Master is a name node here, and the slaves are data node. Okay, this is name nodes, and these are data nodes. These machines are installed in a network, and these will be connected to each other. And what is the roles of name node and what is the roles of data node? We will look at them in detail. The main functionality of the name node is maintaining a metadata. Your name node maintains a metadata of our data. Your name node is like a master where you will assign some task to the data nodes and where the data nodes work as a slaves. And if anyone wants to store data into the cluster, the actual data will be stored in the data nodes, the slave nodes, in the form of blocks. We'll see what is a block in detail. Okay, what is a Hadoop block? We'll see detail in further slides. As I said,
Okay.
Hadoop. Go ahead.
Yeah, here I have one question. Is it all data nodes are like interlinked without like a name node?
Without name node, no. With the name node, it will be interlinked. The data node, when
Okay.
you
And
say data,
the diagram says like all the data nodes are like it interlinked. That's what I got out actually.
see, all the data nodes are interlinked, and also they are interlinked with the name node. All data nodes are again linked with the name node. All the data nodes, these are the data nodes, as I said, these are the data nodes are linked with the your name node, right? And these data node internally also will be connected each other.
Okay. Okay. Okay.
Clear?
Yeah. Yeah.
Okay. So the the whole data, the data, whatever the data was storing into the cluster, that data will be mainly stored in the data nodes. Your name node will not store any data. If you want me to take a real time example, I'll take an example. Like in a project, in a real time, in a project, we'll be having a different hierarchies: manager, team lead, and team members. Let's take a small example. Team here, the team lead is like our name node. Team lead is like our name node, and team members are like our data nodes. Okay, so our team lead will be assigning the tickets or will be assigning the work to our team members, right? It doesn't mean that he will not do any work, but he will also doing that. But when I'm comparing with this architecture, let's assume that your team lead is not doing any work apart from the managing. So what is the team lead's roles and responsibilities? He knows all the details about the team members, like what technology he knows and what is he capable, and whether I have to assign this task to him or not. If I assign that, whether he is able to complete or not. If he's not able to complete, to whom I have to assign this. All these kind of our skills and our capability, everything will be known by our team lead. When the client assigns the tickets, or when a client raises a task or a development task or tickets, what our lead will do, the lead will assign the work to members, I can say team members, and he will start monitoring us, like what is the status, how long will it take to close the ticket, and he will be keep monitoring, and he will keep getting the status from us, right? He will be maintaining one Excel sheet. Our team lead will be maintaining one Excel sheet.
Okay. Ravi, I have one question here.
Go ahead.
Okay. If like see, you were saying like we have the name node and like data node. If data node internally it talks each other,
Mm-hmm.
what is the purpose of main node apart from like metadata management? Is it talks each data node internally?
Yes. Yes, your name node will talk to each data node. Ideally, it's the other way.
No,
Our data nodes will each talk to the name node.
no. My question is data node to data node.
Okay, I'll. It is too early to answer that question. I'll show you why our data node will talk each other. I'll teach. I'll answer that question. Okay.
Okay.
There are some scenarios where they want to talk data node to data node. I'll show you that scenario.
Okay.
You might have think. Assuming the prospect of the storing the data. But when it comes to processing the data may be there in different machines, right? The machine 1 or data node 1 may require some help from the data node 1 or data node 2. I'll show you that example. How the data will be copied, how the name node or data node will talk. What is the channel and all. Okay. Now we are just trying to understand what is the Hadoop cluster. Am I clear, Jay?
Yeah.
Okay. Now what our team lead will do, he will keep managing us, and he will keep maintaining on Excel sheet which guy is doing what and what is the status of them, right? The same way here, the name node will maintain a metadata. Apart from that, he will not do any work. He will be assigning the work, and he will be monitoring, and he will be keep getting the responses or keep getting the reports from the data node. These data nodes will keep send the heartbeat. We'll say heartbeat. Those heartbeats are RPC call. It's a remote procedure call. So which contains a block report, and which contains the state of the data node, which contains what it is currently doing, how much space is available. All the details will be keep sending to the name node. And the data node to data node, the communication channel is HTTP, Hypertext Transmission Protocol. This is HTTP, and this communication is RPC, and this communication is HTTP. We'll see in detail the each and every point. And every 3 seconds, your data node keep reporting to name node saying that I'm alive and I'm doing this process. So they'll be sending every 3 seconds. They'll be sending the report to the your name node. If your name node didn't receive a report from the data node for 10 seconds, and it will treat it as that data node is not alive or it died, and it will report it, and it will make an entry in the name node's repository. Ideally, it is a registry saying that this IP address will mark as dead. Okay. And when it starts again, let's assume it come up and it starts sending the RPC calls or reports heartbeat to the name node, and name node will remove that entry from the its registry saying that yes, this IP address of this machine is alive. Clear, guys?
So can we make the timing like how frequent? Okay.
Yeah, by default at 3 seconds. And
Okay.
uh, the timings, we don't have the option to change these 3 seconds time. We cannot, but we can change the attempts, how many attempts it has to wait, how long it has to wait, whether to decide whether it's live or dead. We can assume that we can configure that how many attempts it can do.
Okay.
Yeah, we'll see that as well. Clear? Okay, I'm going back to the slide. Okay, the Hadoop cluster looks like this. The data nodes, and it will be a collection of the racks, and each rack will contain some and data nodes and secondary name node and data nodes. Secondary name node will talk. It comes in a special case, special scenario. We'll talk about the secondary name node in for another 2 3 slides. Your name node can be installed any of the rack, and as well as your data node also can be any of the rack. And there is no specific rack it has to be there. It has to be there always in one first rack or second rack. There is no that kind of constraint. And also your client can be any of the machine, or it can be any of the hardware device in the rack. It can be any of the rack, because all the racks are connected with the switches and with the highly high network bandwidth. And don't worry about the job tracker and task trackers. We will see these are the processor, these are the daemons which will running in the background. So I'll explain them in detail when it comes to the that point. So like job tracker and task tracker, for these are this that also follows the master slave architecture. We'll see them in detail. Okay, is the slide is
Yeah,
clear? Yeah,
Ravi, I have a question here
yeah, go
actually.
ahead. Yeah,
Mhm. So, like, if you now you said job tracker is the demand, right?
yes,
It's not a machine.
Yeah.
But actually, that means actually, like if I see the physical hardware rack 1 and rack 2,
Hmm.
so here job tracker and name nodes both they reside in the different racks, not on the same racks.
Correct. That I'll explain you, Ram. See, the job tracker
Okay,
can run on the name node, and task node will run on the data nodes. Okay. When you want to, if you want to make a job tracker special machine, we can go ahead and make it, but we'll see them in detail.
okay, okay. Yeah.
First, we'll look at what is the name node and what is its functionality. We'll see, and what is the data node one, what is its functionality. And job tracker and task tracker will not come into picture while storing the data. The job tracker and task trackers will come into picture when you are processing the data. So we'll talk about them detailedly when we are going to process the data. Okay, this is the high level architecture of HDFS. Okay, okay. Now let's try to understand about the each component, like what is the name node, and don't worry about the backup node. Even the backup node is nothing but our secondary name node. We'll talk about the backup node in two more slides. And these are the data nodes where they store the data, and where the actual processing will happen in the data node only, like a team member. In the team members will do actual work, and they will make sure that the work is get it done. But who will manage? Our team lead will manage. Ideally, it's just an idea. Okay, it's not a really team lead will not do any work apart from the managing. He may do some work and he may fix some defects in the real time, but to understanding, I'm just correlating with that. Okay, now these data nodes will store actual data, and these guys will process the data. But when it comes, these guys has to be managed by someone. How they will manage? And your name node will manage. Your name node will have all the details about data nodes, and what are the data is stored in the data, these data nodes, and what are the slots are available, what is the capacity of it, how many jobs can run at a time in that node, or is there any currently is running any task. All these management details, all these details will there with the name node. Okay. And okay, see here we'll see the detail of the architecture. Is it clear about the architecture? I mean, what is the name node and what is the data node? Any doubts there before going into the slide?
Yeah, Ravi, can you go back, please?
Okay.
So here, every data node, so like the two-way export and the import,
Hmm.
are the databases?
No, no, no.
Are the data warehouse?
No, no. Actually, this symbol is representing storing the data, nothing else. It is just representing
Okay,
it internally stores the data.
okay.
Okay. Okay. Any other questions, guys? Am I audible to everyone? If anyone are you guys are facing any problem, knows about this voice or screen sharing? Everyone is clear? Okay, so I think everyone is able to see my screen. Okay, let's move on. Detail architecture. As is explained before, the data will store the actual data will store on data nodes, and those guys are the responsible to store the data, and the metadata will be storing on name node. Now, a client, he wants to store some data into a cluster, and he sent a command, he issue a job, he submitted a job. I want to store this data into your name node. Now, I mean, I want to store the data into cluster ideally. What he will do, first he will talk to the name node. Without we talk to the name node, we will not come to know what are the data nodes are available. The same way, the client or the end user will not know who are all the team members in the team. Ideally they will know, I mean, who are all working for this project and all. If you take other scenario, so our client will not never know that these are the data nodes are there in the cluster, these many data nodes are there in the cluster and all. The client will not know about them, and where and all they installed, whether this they're in rack 1 or rack 2, rack 3. They never know that. When they want to write some data, when they want to store some data into the cluster, what they will do, they will approach a name node. And they will also say that this is my configurations. Like they will say this is my replication factor, and they will say this is my blocks size. That will be configured already. Or they can also say individual. When they're sending the data, they can also say that this data has to store in these many replicas, and this data has to store in these many blocks. I mean, this is my block size as well. They can inform. Using this information, your name node will send you the data node's location in a sorting order. Sort on based what? The distance. The distance to the client. Let's assume my client is there in rack 1, and the client in the rack, the client is there the very first slot, and data nodes are there in the bottom. I mean, next slots on board. And the name node who are all near to the client with respect to distance, or with respect to a network distance, I can say. And it will pick them, and it will check whether the data space is available or not, what is the their states and all. Your name node will know. Your name node knows the detail about the data nodes, right? So what is the space available, and what is the capacity of it, how much data it can store, how much data it can process parallelly, how many jobs can, or how many core or how many slots are available in that data node. These details will be known by your name node. When I issue the command, or when you submit the job to write the data into data nodes, your name node will pick some of the data nodes from the cluster. It has some policy how to pick and all. We'll see them in detail. It will pick some data nodes, and it will give to the client in a sorting order, which is based on the distance. The sort will happen based on the distance. Then will start talk to the your client will start talk to the data node, and he will create a channel, or I can say a pipeline. Then he will start sending the data. He will start sending the data. How the data will be stored here, in the form of blocks. We will see who will divide the data, and who will data into the blocks. We will see them. What is the block size? Why it is a block size? Block here bigger in the HDFS. We'll see that details. Let's just for time being just understand the file. Whatever the data I want to store, that data will be broken into pieces. That those pieces will be sent to the data nodes. Who will send? The client. The client directly interact with nodes, data nodes. Ideally, who gave this address? Your name node is given addresses to client. If name node will give, you can go ahead and store your data into these data nodes. Let's assume data node 1, data node 2, and data node 3. What your name node will do, it will give the okay, your employee data you can go ahead and store in these machines. And you can, what if you specify any configurations, like I want to block size this, I want the replication of this. If you specify, it will store accordingly, or it will store by default block size, and it will take the default replication. We will see write and read process, how the data will read and how the data will be write into the cluster detailing. Now we are trying to understand here what is the data node and what is the name node. Clear, guys? Okay. Client is a machine where you will execute, where you submit a job, from where you want to store a data. Client is a machine where you actually submit a job. Let's take, if you take a traditional approach, where we are writing a query, where we are writing insert query, that is a client. And who is executing? The client can be a data node, a client can be a separate machine out of the cluster, a client can be on one machine in the one separate machine in the one of the rack, or one of the in a cluster, one of the rack in a cluster. It can be a data node also. We can take any one of the data node as a client, we can make use of it. Clear? Now,
Ravi, in real time, Ravi, in real time, like how the client, do we consider one of the machine part of the Hadoop system as a client, or do we keep a separate one most of the times?
see, in a real time, we'll keep it as a separate machine, and who will pick the data from one machine and who will send it. And
Okay.
it's also completely depends on how you design your architecture and what kind of data you're storing in the cluster. Some machines, right, will be the data will be keep loading into one machine, and from that machine only we are picking the data and we are storing the cluster. So now here, whoever is storing the data, he's a client.
Okay.
And I mean locally, who are storing the data into local and he's sending to the cluster, he's a client. Or some cases what we'll do, we'll use one of the machine from the rack, and we'll from there we'll execute the job, and wherever the job is executing, that guy is a client. No need to be always the same machine. Clear, Rama? Hello.
Clear, Ravi.
Okay.
Yeah.
And now, as I said, as Jay asked a question, why, how it is a data node to data node communication. Let's the client will not talk to all the data nodes. When the name node, when storing the data, when your name node as given the IP addresses or addresses of the data nodes, your client will talk to one of the data node. Your client will talk to one of the data node which is near to him. Okay, then he will create a pipeline or he will create a channel and he will start sending the data. Once the data is coming into one data node, that data node will transfer to the other data node, and that data node will transfer to other data node. Here, we need a communication between two data nodes. Clear, Jai? Your doubt? You were asking before why the communication between
Uh,
two.
yeah, I have one question here.
Go
See,
ahead.
is it that is the case if they take us 10 data nodes are there, then 10 into 7 into by 2, that is
What is the
uh,
calculation? 10 into 7. I mean, I didn't understand. Could you please elaborate?
okay, no, no. It take us 4 data nodes are there,
Okay.
okay.
Mm-hmm.
Then 4 into 3 by 2, that means 6 link will be there in between. Am I correct?
No, all are already connected internally. When you make a connection, when you make a cluster, when
No,
you design a
what I
cluster.
mean to say, no, no. What I mean to say is, take as A, B, C, D.
Okay.
Okay,
Okay.
A connected to B,
Mm-hmm.
A connected to C, A connected to D.
No, no, no,
Am
no,
I
not
correct?
like that. Not like that. A to B, B to C, C
That
to
is
D.
sequential. I mean to say. A to B, B to C, C to D, D to A.
I mean,
That means,
it's all are internally connected again. A to C also will be connected. A to B also will be connected. These are topology, network topology, mesh topology.
yeah, okay. It's not like end-to-end connection. The each that means all not internal, only mesh connection. That's
Yes,
what you mean to
yes,
say.
yes, yes.
Okay, okay.
Yeah. Okay. Now we'll see what are the communication channels between these nodes. The data node to name node, which is sending the heartbeat report, which is sending the it's that communication channel is RPC, remote processor call, and the data node to data node, the communication channel is HTTP because it has to transfer some data, and your client to data node is again HTTP where it has to send some data, and your client to name node is a RPC, remote processor call. It will just send the some addresses, IP addresses. It will not send any real data. Okay. As soon as your client is stored data into the data node, once the data is coming to the data node, successfully stored, your data node will intimate to the name node saying that yes, I have stored this block into my machine. I mean, it's memory, local persistence. Persistence memory means it's a local memory. That when the data is successfully stored in the data node will send the report to a name node, and your name node will make an entry saying that this block is belongs to this file, and this block is stored on this data node. Like file to block and block to data node entry will be there in name nodes metadata or name nodes registry ideally. Clear,
Can
guys?
you repeat again, Ravi?
Okay.
Can you repeat again, Ravi?
Yeah, so I have stored an employee data into the cluster. When I the data will be broken into the pieces blocks, and as soon as store the data into the cluster, when the block is successfully stored in one data node,
Mm-hmm.
one data node is received the block successfully, and that data node will report to the name node saying that I have received this block, I have received this block successfully, and that entry, I mean, it says that I have stored successfully, and your name node will make an entry in the its registry, it's the metadata saying that this block is belongs to this file, the employee file. Let's
Okay.
assume that employee file, and this block is stored in this data node, and
Okay. Okay.
and the replications are stored in these locations. So
Okay.
file to block, block to node, I mean data node. The entry will be
Data
available
node.
in that entry will be
Okay.
available in your name node's
Okay.
metadata.
Okay.
We will see where it will write the data, where whether the name node will maintain separate files or separate database or some those details we'll see in another coming slides. It has a special properties or special file names. It has special names for it. We'll look at them. For the time being, you just say it is storing somewhere, or just assume that it's maintaining some file. In that file, the entries will be going into that. This is the file, and this is the block, and this block is belongs to this data node, and this data node has replication this many. Okay, I mean that block has this replication and all. So it will maintain some data. Clear, guys? Any doubts? So may I go to the next slide. Please respond according to that. I can take consideration. It's clear to everyone or not. Any doubts in? Any doubts in?
Uh,
Yeah.
yeah, can you please explain that our replication concept once?
Okay. Yeah. Replication has actually a special slide. Anyway, I'll here the slide shows that replication. I'll explain the replication. When I want to store an employee data or a stock data into a cluster, we will be by default the replication factor. The replication factor is how many copies you want of the same data. How many copies? Because let's say if I store whole data in one machine, as you saw in DFS, and if that machine is crashed, some problem, and we may not be able to recover the data. To avoid that situation, to make fault tolerant, our HDFS come up with a concept called replication factor. Replication factor is when you want to store the data, how many copies you want to store the same data into the cluster. Let's assume I have 1 GB of data. I want to store in the cluster. My replication factor is 3. It's a default configuration, and that in the cluster the data will be copied thrice. It means it will be 3 GB data. In the cluster it will be 3 GB. It will not stay only 1 GB. It will store in 3 GB, but it will make sure that it will not in the same machine or it will not in the same rack. It will make sure that the data will be stored, the replicated data will store in multiple machines and different racks. That is a block replacement policy. We will see in detail when the block replacement policy comes. The replication is simple in a simple terms like how many copies you want, to store in the cluster, how many copies of your data you want to store in the cluster. Clear?
Ravi,
Okay.
in this case, can I consider number of data nodes in the cluster, minimum number of data nodes in the cluster should be equal to replication factor?
Well, good question. See, yeah. So I have, let's assume I have only two data nodes, one name node is there. Okay, and my replication factor is 3. And when I store the data, it has to take 3 blocks, right? It has to, one block has to be replicated 3 times, right? Let's assume that
Yes.
I'm storing one file which is 100 MB, and so 100 MB means it will come 2 blocks only. The default block size is 64 MB. That can be changed. We'll look at the more details. Why it is only 64 MB? Why can't it be more or less? We'll see them. Okay. Let's assume the default block size is 64 MB, and my file size is 100 MB. So 100 MB will create 2 blocks. One is a 64.
Now I have 6 now. Yes. Now that means I have 6 blocks now.
No, I'll come to that point. So I have two data nodes, one name node, and my data has 100 MB. It will give us the two blocks. One is for 64 MB, other one is 36 MB. Okay, the 64 MB block will start storing into the machines. But the replication factor says that 3 machines has to there, three places it has to store. But I have only 2 node cluster, 2 machines only available. Will the job success? Yes, the job will be success. Why? Along with this replication factor, there is a one more replication factor called minimum replication factor. That's called min replication factor.
Okay.
And that configuration says that minimum how much data I want to store, like 100 MB. Yes, minimum 100 MB you store. I mean 2 blocks minimum, you store 1 block at least. I mean once at least one time. It means at least one time you store complete data. It's not like partial data. Complete data you store at least once.
Once. Okay.
Okay. If you go ahead and change the minimum if you go ahead and change the minimum replication factor also 3 and your replication factor also 3, but you have only two data nodes, that case the job will not success. Let me put in a detailedly. Let me take this scenario. It's a name node and I have only two data nodes. I have only two data nodes. Okay, this is, let me put name node and this is data node, and I have a file which is 100 MB and my block size is 64 and replication factor is 3 replicas. Okay, when I say I want to store this data, let's assume he's a client, and when he wants to store the data into the cluster, what he will say? He will say that I want to store this 100 MB into your cluster, and these are the blocks, and your client is already divided into blocks. Those details we'll look into, how it is divided, who will divide it, those things we'll see. Let's assume that the data has been divided into 2 blocks. It's a B1, which is 64 MB, another B2, which is 36 MB, right? Because my total whole data is 100 MB. It is now it has to store 3 replicas, like
B11, B12.
yes, B11 and B12.
B12, B1.
B1,
B11 also,
B11,
right?
no, B1 the original, and B11 and B2,
Okay.
B12,
Okay.
and
Okay. 3.
B2, B21,
B21,
B22. Okay, now
Okay.
these blocks I want to store in a cluster. What it will do, when it will say that this is the replication factor and this is the block size, it will give the data node addresses. So name node doesn't find any other data nodes apart from these two, right? Then what it will do, it will give these two addresses, and your client store the data into these machines. It will store B1 here, it will store B2 here. These are the original blocks, and it will store here B21 and it will store here B1 1, and
Okay.
here it will make sure that it will not store the duplicate data. I mean same data it will not store, same block will not store. Now I don't have the third, I cannot store because only two I can store. If I try to store B22 here, if I try to store B22, so already B21 is available, which is a duplication, I should not store. And if I try to store here as B12, it is again a replication, I should not store, right? So again, as I said, it will be success. It will inform that to name node saying that I have successfully stored B1.
One set.
Your data node 1 will say B21, okay, and data node 2 will say I have stored B2 and B11. Okay, this entry will go into the name node. Now
Mhm.
it should uh, it should have a 3 replicas, but it stored only 2 replicas. Then how it is possible? As I said, your we have one more configuration called minimum replica. How many? It's by default it's a 1, and the actual replica,
Okay.
default replica it is, which is 3.
3. Okay.
And maximum replica, there is one more maximum replica where you can store 512 blocks or 512 blocks like B11.
That is the maximum.
We can change it. We can go ahead and change it. Again, depends
Okay.
on the
By default,
cluster.
what is the maximum? By default, what is the
512,
maximum?
512, 512.
In Apache? In Apache?
Yes, in Apache.
What about Cloudera?
They will be having the see. Okay, Cloudera default block replication, maximum replication. Even those are by default will be same source code in Lirama. They will have design the same code on it, right? So version to version will go
Okay.
different. So they
Okay.
have a CDH4, it's a Cloudera 4, Cloudera 5. They have different versions. You can
Okay.
they can go ahead and so again when you are considering this max replica, you should consider about your cluster size as well.
Okay.
Okay, clear, Rama?
Yeah. So that means here, that means now with this configuration, yeah,
Mhm.
go ahead, Ravi. Sorry.
Okay, so it is stored only 2 blocks, but it's supposed to store 3 blocks, but it's stored only 1.
Mm-hmm.
Okay, so because why it is success? Because the minimum replication factor is 1. The cluster says that
Okay.
our configuration says that in a cluster at least you store 1 copy, like B1 and B2, at least 1 copy there, fine, success, the job is success.
Mm-hmm.
That
Okay.
is the reason it is stored. But when the block scan happened at backend, I'll talk more about the block scan. The block scan says it is an under replica, supposed to store as per the configuration, it's supposed to store 3 blocks, but it store only 2 blocks. That will be say under replica.
Mm-hmm.
When you install a new machine, it will automatically store the third replica.
Okay.
When you install third machine, it will automatically replace the blocks. That time the
Yeah.
cluster is healthy. So when you query the report, when you ask the report, it will say these many are the under replica. So these many of the blocks are successfully stored and these many blocks are the under replication. It will show that details. Clear, Rama?
Yeah, here I still have a question, Ravi.
Go
Because
ahead.
here minimum replica is 1, that way success. Like in the configuration, if the
Mhm.
minimum replica is 3, then will it fail?
It will fail. Job will fail. It will not store any data.
Oh, okay. That means so here the number of data nodes in the cluster should be equal to minimum replica.
Correct. Correct.
Okay.
Yeah.
Yeah.
Clear, right? Yeah. This
Thank you.
is
Yeah.
this is the how it will store in the cluster. I mean, it's not out of the our architecture. This is out of the architecture concept. This is it will comes in architecture concept only. Okay. And Ramya was
Okay.
asking,
Yeah.
does the replication apply at a block level or node level? It's a block level, Ramya. The replication is block level. Node level, I mean, I didn't get to why you're thinking it's a node level. The replication is belongs to the
Block
data.
level or the file level?
It's a block level. It is a block level.
So that means here, sorry if my question is wrong. So this replication factor defines
Mm-hmm.
how many. Okay, sorry. Yeah, that makes sense. That means number of copies, right? Replication
Number
is
of
the number
copies.
of copies each block. Each block,
Yes,
right?
yes.
Okay.
Each block, the number of copies. And
Okay.
also, if it stores successfully B1 and it's not able to store the B2, somehow some problem happened, but the job will not success. Until unless the complete whole data is stored in the cluster, then only job will success. There is no
Okay.
possibility to store the partial data. It will not store the
Okay.
partial data. It will store whole data. Then only say the job is success. Else it will show
At least 1% of all data.
yes, one copy of the data. At least one copy of the data has to store complete data. Complete data. 100 MB of the data. If you take this scenario, if you store 100 complete 100 MB, yes, the data is stored successfully. If you say 64 MB, 64 first block 1 is stored successfully and block 2 is not stored due to some issues and it's failed, but we cannot say it is a successful job. It is a failed. Clear, guys? Anyone has any doubts? Okay. May move to the next slide. If anyone has any architectural doubts or know how it is storing, and I'll still go ahead and explain. Before getting into the what is name node and what is a data node, before getting into the what are the daemons are running, if anyone has any doubts about the architecture, please go ahead and ask me and I'll try to answer. I'm putting the slide. If anyone wants to see and ask me the doubts, you can go ahead and see the slide and ask me. Okay, just allow me 1 minute of time. I mean, few seconds of time. I'll take some water. Is this clear, guys?
Ravi, I have a question.
Go ahead.
Do you mean 64 MB block data will be saved in one block and remaining 36 MB will be saved in another node?
Yes. No, could you please repeat? I'll try to elaborate more. Could you please repeat? You have 100 MB and it has been divided into two blocks, block 1 and block 2.
Do you mean that block 1 will be saved in one node and remaining that the block 2 will be saved in another node?
Correct, other node.
Okay.
See, first it will try to spread. Block 1 will go on one node, block 2 will go on one node, block 3 will go on a different node. The replications, the duplications, it will your data node or your cluster will make sure that the duplicated data will store in the same machine. We have seen block 1 and block 1 block 1 2, and block 2 block 2 1 block 2 2, right?
Okay.
Let me show the diagram once again. See, here I have, these are the two different blocks, right? This is the one block and this is one block, two blocks, and two blocks has been divided whole data. It's divided into two blocks, and the block 1 has a replication of B11 and B12 because it has to three replica, right? Three blocks are came.
Okay.
1 2 3, and block 2 also come three replications. Okay, how it will store the data?
Okay.
First it will store one block into one machine, other block into other machine. Okay, here when it try to store again B12 or B11, because the same data, the block is same, this block and these blocks are same, because those are replications only,
Yes.
those are copies, so it will not store in that machine. These will not go to data node 1. This has to go to data different machine because that same data. Okay. Yeah. Yes, Rama. There it can be possible. The different blocks of the same file can store in the single machine. It can possible. I understand your question. Do you want to say that in the data node 1 can I store B1 and B2? Yes, it can be possible. Yes, the duplicated data will not store in the same machine.
Okay, Ravi. Like if the first case is possible, then that's like an ordinary DFS system.
Yes.
Like if
yes.
Okay, that
If
means
I have
the
only,
Hadoop can also carry.
yes,
Yeah,
that
please.
that is the reason we have split it into blocks. We are storing into multiple machines. If it's stored in a single machine, again it will become a DFS.
Okay.
But
That
this
means Hadoop
scenario,
also can be worked as a DFS.
yes, when it has only one node, one
Okay,
data node,
yeah.
one
When
daemon.
Yes. Okay.
Okay, but here it will make, while processing, it will make small difference because it depends on the cores available in the data node. How many cores? I mean, processing. I'll come to detailedly, like a 4 core or
Okay.
8 core, 10, 18 core, 32. The cores will come, right? Those many processes will start running parallelly. Those many map jobs will run parallelly. Those things we'll see. But
Okay.
anyway, that is the reason always it will choose multiple machine to store blocks.
Okay. Yeah. Sure.
Yeah,
Thanks.
your doubt is clear, right?
Yeah.
Okay, guys. Rama doubt was can it store all the data into one machine? Like the B1 and B2 won't hold data, the B1 and block 1 and block 2 in the same machine. It can store, but the problem is how it will be different from the DFS. Whole data is in the same machine. It will not be different from the DFS, right? The data has to be processed in the same machine again. If this complete machine fail, we will not get the recovery. When case of only one name node you have and one data node you have, this is possible, but still this is not recommended for HDFS. Any doubt, guys?
I have a question.
Go ahead.
In the same scenario, if the data size is 200 MB, how it will be stored?
200 MB. Very good question. Let me divide the 200 MB. How many blocks will come? 2 blocks only again. Let's assume we got the 3 blocks. We got the 3 blocks. Let me clear it, and or else let me take one more. I don't think it will give one more page. Let me draw here. You have two names only, right? Same scenario you are taking, right? 2 data nodes only we have. So let's assume this is name node. Sorry guys, my handwriting is too bad, but I'm making use of to explain something. Okay, now my data has been I have a more than 250 MB. I have its size is 250 MB. Then I'll get the 3 blocks, right? Block 1, block 2, block 3, irrespective of the size. We don't need to worry about the size. But block 1 will be 64 MB, and this is also will be 64 MB and 128, and this will be 128 plus one more 64 MB. Okay, now let me calculate it. How many blocks will come? 128, 128, 256. And means it will come block 4 also. It will come 4 blocks. Right? How it will store? This is what your doubt, right, Ramya?
Yes.
Okay. So this guy is a client, and this guy is talking to here. This is a client. Now, first, what it will do? It will take the first block. It will store in data node 1. The same block will be replicated here. When it is a B11. Okay, and it will make sure that B2 will go to here, and it will make sure that B21 will come here, and it will make sure that B3 will come here and B4 will come here, and here it will come B41 and B31. Clear, Ramya? Now your data node 1 doesn't contain the duplication, and your data node 2 also doesn't contain the duplication, but it has a different kind of blocks. Here B1 is there, B3 is there, okay, and here B2 is there, and your B4 is there. Is your original data is in different machines? I mean original blocks, I can say. Okay, your 250 MB of data has been spread into 2 nodes, 2 different nodes. When you want to process, you have to process B1, B2, B3, B4. Parallel it can process. If something is fails, I can get the data node 1 is failed, I can get the recovery from here. If data node is failed, D2 is failed, I'll get the recovery from here. I have a recovery as well. Right? Clear, Ramya?
Yes, I'm clear.
Okay. So, does anyone has any doubts? Okay, let me go back to the screen. Please let me know if anyone has any doubt. So, if you understand clearly this one, I'll try to correlate with the Hadoop features now. I want to correlate with our Hadoop features, what we have seen yesterday. We have seen the replication where I can, if the one data node is failed, We have seen one feature that where I can get the data. And other one, if that my data is keep increasing, what I will do, I'll go ahead and add one more data node here. I have kept it here. Talk. See, if my data node, my cluster is, as I taken early, 2 nodes, my data is getting growing, I'll just go ahead and add. It can be done on the fly. While adding the data or while removing the data, no need to stop the cluster, no need to make the cluster down. The cluster keep running. We can add the data node, but we have to use some command, administration command, where you want to refresh the cluster or refresh the name node. We'll see that details later point of time. When it comes to the commands and all, we'll see that. So my data is increased. Yes, simply go ahead and add one more data. And I'm seeing here parallel processing, right? My data is getting processed parallelly. Here I have, because here I have B1, here I have B2, and here B3, and B21, B31, B11. I have a different data in different places. And when I launch the job, when I want to process it, I can process the parallelly. I can process parallelly. The parallel processing we are able to see here. Parallel process is one of the feature of Hadoop. And the cluster is commodity hardware. These are a commodity hardware. You can say the RAM size is 64 MB, 64 gig, and your hard disk is 500 or 1 TB gig. Depends on the data. We'll go ahead and increase the our clusters, which is a commodity hardware, and cost is less. When you go DFS or when you go traditional approach, you should have a specific or special uh, hardware. When it comes to the Hadoop, we can go with the commodity hardware. And parallel processing, when it do the parallel process, will achieve the results in very quicker time. It's not time consuming. We are getting the results in very less time. Are you guys able to correlate with the features yesterday what we have discussed? And it's a scalable. I can go ahead and increase the data nodes, and it's a fault tolerant. Right? And as I said, no need to be, it can be heterogeneous cluster. It can be, no need to be same data nodes. It can, no need to be, it has to run. If I say, let's assume it is running on CentOS, no need to be all the machines run in same, same ways. It can be Ubuntu, or it can be something, a Linux Red Hat Enterprise, it can be something else. Right? But it should be a Linux flavor. Heterogeneous cluster, data locality. Here, when you process the data, wherever the data is there, our computation will go and process in there parallelly. Wherever the data is there, it will go and process in that location. It will process here, it will process here, it will process here parallelly. So we are achieving the data locality here. We are achieving the data locality. And let's assume while processing this, the data node is failed. We don't need to worry. Your name node is that much smart where the same block is available. Where the same block is available, it will go ahead and launch the same job, that location, and it will run the job. It is that much smart enough to identify where the block is there. It will go ahead and launch the same job there. That is called speculative execution. We'll see detailedly later point of time. It is called speculative execution. Okay, other two jobs are running very quickly, are finishing 80% very quickly, but still the other fourth one is taking so much of time. It's not even completed 10%. It will wait for some time and look at the status of this data node. If it is not able to process due to some reasons, either it can be a memory issue or it can be some other processor running on this machine, the same, it will not wait to finish this job. What it will do, your name node, or ideally it's a job tracker, your name node will launch the same job wherever the replication is available. Let's assume that replication is available here, and it will start the same job here, and it will also start processing, or it will also start processing whoever finishes first, let's assume this guy is picked up and he started finishing it and he finishes 100% very quickly than this guy, then this task will be killed and this task will be taken into consideration. These results will be taken into consideration. Here we are achieving the data locality as well. Am I clear, guys?
Yeah, Ravi, I have a question here.
Go ahead,
So
Rama.
in yesterday, yeah, within this one of the property. So this is actually under one of the property. Like if I execute one of the SQL command on the client, instead of we getting the data from individual machines, now we are sending our executable onto the individual data nodes.
Correct, exactly, correct.
That is the one beauty of Hadoop. Then here, so while sending the executable onto the data node, so this executable will be sent onto every data node, or will it be sent to a certain data node based upon by communicating with the data name node? How it will be?
Okay. Here it will send to the all the data nodes wherever the data is available. See, let's assume the data node 1, data node 2, data node 3. The whole data is block 1, block 2, block 3. The whole data has been split into 3 blocks and that data is available in 3 nodes. Now, my competition will go into all 3 nodes and all 3 nodes will start processing parallelly.
Okay.
Yeah, it will create a separate JVM and it's ideally a Java program, right? It will execute in the Java JVM. If you take a big query, if you take a high query, everything will again convert into the mapped jobs, which are the Java, Java processes, I can say, Java execution.
Okay, then where the consolidation will happen? Like in the same example, like let's consider I have the replication factor of only 1. And I have the batch size of like 250 MB, the earlier example. Now I have it like 3 nodes. That means each block is on the individual ones. Now I want a complete data. Now the executable has been sent on to the 3 data nodes.
Correct.
That means that means on the data node 1, I got a some data. Data node 2, I got a some data, and data node 3, I got a some data.
As output.
But my SQL, I need consolidated data. So where the consolidation will happen?
Very good. So a very good question, Rama. So I would like to say it's very early to answer that. We can see in the competition, but I'll just try to give you a small introduction for that. Here, while processing, as I said, we have a map and reduce. Right? We have a 2 processes. One is a map, another one is reduce. And if the consolidation will happen in the reducer phase. And there is one more process, and what it will do, the output will be there, right? It will start copy and where the reducer will start. Let's say the reducer, I mean the competition aggregation, I can say. The aggregation may execute this machine, or it may execute this machine, or it may execute in this machine. Depends on the slot availability, and it will start doing that aggregation. We'll see in detail in the coming slides, Rama.
Sure. Yeah, at least I got one way, like what is the answer is, maybe how it happens. Yeah, sure. Yeah. Thank you.
Any questions, guys, from architecture level? Then I'll move to the next slides. Or are you guys are okay? Or any doubts? Thank you, Rama. Guys, please respond. So according to your responses, I can understand whether it's clear or not. If it is not clear, please let me know. I'll start explain one more time. Okay. Okay, very good. I think most of the guys are clear. And if anyone has Jay or Krishna, if anyone has any doubt, fine. I think it's good to continue the next slide. Okay, guys, it's a 7:25. Okay. Yeah, it's 7:25 a.m. in India IST, and it might be different for you time. Do you guys want me to continue for the next slide, or do you guys want me to stop here and continue tomorrow? According to your responses, I'll continue. Okay. What about other guys, please? Yes, we have a training tomorrow as well. Yes, we have a training, guys. Tomorrow, make sure that tomorrow we'll spend more time because still we not at least tomorrow we'll spend 2 hours time. Okay, guys, tomorrow we'll be spending 2 hours time. Please make available yourself, please, because tomorrow we'll be looking at what is the name node and how it will work ideally. What is the data node? How it will work? What is their functionalities? We'll be going to see their functionalities tomorrow. If you're clear with these functionalities, it will be easy to understand further discussions or easy to understand uh, how command is executing, how the command is executing a backend, how it is processing or how it is compiling or executing. You'll be easily understand where the data is storing, how it is managing. All those things we'll be looking at tomorrow. Make sure that tomorrow we'll spend 2 hours and we will finish the session. And Monday onwards I want to start commands. And if it's time permits, tomorrow we will also see a setup. We will also do a setup in our missions. Clear, guys? Please make available yourself tomorrow. Close to 2.5 hours, not 2.5 hours, 2 hours, more than two, at minimum 2 hours I can say. It's not it's minimum 2 hours. It's not like maximum more. Maximum will be 2:15 or 2 hours 30 minutes or 2 hours 15 minutes, because setup has to done in all the machines. Okay, for the setup, the requirement is, if you guys have a 4 GB RAM or more than that, you can go ahead and we can go with the virtualization. If you guys have only 2 GB or 4 GB, I prefer go to with a separate partition of Ubuntu. We can go with a separate partition of Ubuntu, or what we can do, uh, 4 GB RAM will also support the virtualization. Doesn't mean that it will not support, it will support, but it's good to have a separate partition because the execution will be faster. And hard disk is fine, 50 GB onwards anything is fine nowadays. All the laptops are coming good partitions, I mean good hard drive. The
Yeah, one
ram
thing,
cons-
Ravi,
yeah, go ahead.
are we going to install in our system or virtual machine?
Okay, we'll be installing into virtual machines. I mean, in your
Virtual
machine
means
only,
VM.
VMware or virtual Oracle Virtual Box or VM Player or
Okay.
VMware workstation. So it depends on the availability with you guys.
Okay. Is that fine if we install in our systems? It is not possible.
Now,
Uh,
no,
is
could you please
that
repeat?
fine if is that fine if we install directly in our systems?
Yes, you can go ahead and install, but uh, you can go ahead and install. I mean, on Windows you're talking about?
Yes.
No, Windows we cannot install.
Okay.
To install in Windows again, we need some Sigwin tool. So many. You may raise some problems later point of time. So we don't want to
Okay.
stuck that phase. So
Okay.
it
We'll
has to be installed
VMware.
any Linux. Yeah, it has to install any Linux flavor OS. Like it can be CentOS, it can be Ubuntu, or it can be something else, Fedora or something
Okay.
else. But I
Okay.
personally prefer either CentOS or Ubuntu is good. Okay, and the prerequisites like your Ubuntu or CentOS should have a Java installed, and once the Java get installed, on top of that we will install a Hadoop, and OpenSSH also is required. So please install OpenSSH server. I mean, anyway, we'll see these steps in installation or configuration phase. But if anyone wants to try now, or if anyone has a time, or if anyone already has a Ubuntu or CentOS machines, they can try with it. Clear, guys? Any doubts? Please respond, guys. So according to again whether I have to close or whether I have to continue, I'll just wait. Okay, guys, I will be waiting. If anyone wants to talk to me, please can go ahead and talk, or others can leave for the day. There is no further session. I mean, there is no after this. There is no any. I have only Windows Vision. Okay, in the Windows system, we'll install virtual machine. We'll install VM Player or Oracle Virtual Box. In that, in Virtual Box, we'll install the Ubuntu or CentOS. Ramya, your doubt is clear? Yeah. If anyone wants to stay back and talk to me, they can stay back and I can answer their questions. And let me stop.